Hi guys. Today we're going to discuss decision problems and decision procedures. This will be quite important because one of the big advantages of a lot of what we will discuss in this course is the ability to solve an important class of problems by realizing that we can reduce these decision problems into language problems, which we will develop a lot of techniques for solving. So the definition is actually really quite simple. A decision problem is just a problem for which the answer is yes or no. So basically a problem where the solution must be a Boolean. A decision procedure is just a method that we can follow to answer a decision problem. So more concretely, it's a program that will always halt, and when it does, returns a Boolean. So I'll give you an example of a decision problem and an associated decision procedure. So the problem that we'll consider is that we might have some text made up of a series of characters. So in this case, maybe some text made up of zeros and ones, binary strings. And we may have a pattern that we need to find within that text. So you can imagine if you're doing Control F in Word or something like that and you're looking for a string within a document, that would essentially boil down to something similar to this pattern. So more formally, we've got a pattern from the alphabet of 0, 1 and text from the alphabet of 0 and 1, and we've got the length of the pattern is obviously less than or equal to the length of the text, because otherwise the answer would be very trivially no, the pattern is not in the text. So the decision problem is, does P occur anywhere in the text? And the decision procedure is something that we give a problem and a text pair to, and it will return yes if the text contains the pattern, and it will return no otherwise. So some examples might be the text 1001 and the pattern 00. So you can very easily see that this is a yes instance because we can see the pattern right here. Or the same pattern but with a different text, for which we can clearly see the answer is no. Some of you might already be able to see how we can use the idea of determining if a string is in a language may help us in this case. So first, what if we wrote down the pairs of P and T using a slightly bigger alphabet, say 0, 1 and hash? That way we can tell which part is the pair in the string, down as one string, so P hash T. Well, then we could define a language over this alphabet that just consists of all of the strings in this form, such that the pattern at the front of the string is in the text at the end of the string. And we can see how that clearly fits our idea of the definition of a language. Once we've done that, if we have a way to describe that language carefully, and if we've got a way to decide if strings are in that language or not, then we have a way of solving our original string matching problem. So we can see that in this case, what we've been able to do is we've been able to turn our decision procedure, or our decision problem, into a language problem, and assuming that we have a way to solve that language problem, so solve the question of whether a certain string is in the language or not, we now have a way of answering every instance of our original decision problem. This is what we're going to spend a lot of the course essentially working on the tools to do. So it would be a good idea to keep this concept in mind throughout the course, because you'll see a lot more value to many of the tools that we develop in this course. So we've seen now what a decision problem is. It's just something where the answer is yes or no. We've seen what a decision procedure is. It's some method that will always halt and tell us yes or no for instances of decision problems. And we can now have a bit of an idea why the concept of strings and languages and answering questions like, is some string in a language, might be very important for computer science.